Okay. We've solved the first quiz problem. And if you just look at the problem, you see that if you try to solve for G, if you add 5F, not just 5, because 5F is not equal to 5, unless F happens to be 1, and F could be any number at all. It's very unlikely that you want to restrict yourself to F equals 1. If you did, you would just let this be 5, okay? F can take any value. So you can't just add 5 to both sides. Now, once you add 5F to both sides, the solution comes out very nicely. So we start with our equation, 3G minus 5F equals 7Q, and we add 5F to both sides, okay? Then I write the step out. I write the 3G minus 5F plus 5F, because that's what you get when you add this side to this side of the equation. We have two equations here, 5F equals 5F, 3G minus 5F equals 7Q, okay? We're adding these two equations, meaning we add the left sides and we get this, 3G minus 5F plus 5F. And on this side, we get this plus this, which is 7Q plus 5F. Then negative 5F plus 5F is 0 because 5F is the same thing as 5F. So if we add the negative of the thing to the positive, it's 0. And we're left just with 3G on the left-hand side. Then we have 7Q plus 5F on the other side. So now all we have to do to solve for G is divide both sides by 3. So we divide 3G by 3, and we divide 7Q plus 5F by 3. We can't pick and choose what parts of each side we divide by 3. And several of you have done that today, okay? We have to divide the whole same side by the same thing, same quantity. And of course, that quantity can't be 0, okay? And we finally end up with G equals 7Q plus 5F, that quantity divided by 3, okay? Now, I'll note, I think most of the class didn't get this assignment done, okay? If you didn't get the assignment done, then you really need to go to the half credit page and do it so you'll know what you're doing. This is very important. This brings together all the rules for solving linear equations, okay? Now, there are other kinds of equations that we'll see in this course, quadratic equations, okay? Even a little bit of exponential and logarithmic equations, which sound bad, but there's one simple rule that makes them fairly easy. If you know all this, this is a foundation. You have to know these operations and you have to apply them correctly and consistently, which means that you ought to be writing on your paper when you do these. Over to the side, add 5F to both sides. Write that out over here. I didn't have room, and I'm not going to do that because I've already done that several times. So you can always look back. And then divide both sides by 3. Don't just say divide by 3, divide both doggone sides by 3. Otherwise, you get that common error where you divide one thing by 3, but not another. Every term in the whole equation has to be divided by the same number. Otherwise, the equation no longer has the same solutions. It's no longer the same equation. The problems, right? Ask yourself, okay, because nobody got everything right. Most of you did some things right. How are you approaching these things? Are you writing these out in your notebook? You really should have a dedicated notebook for this course where you write your homework out. That way, if you're asked to submit a copy, you can do that. Okay? If you tell me, oh, I don't have a smartphone, you didn't have time to get to the copier, can you take a look? Open your notebook to that page, I'll take a quick look. Okay? Then I'll or possibly add some points. Remember, now the alternative would be for me to give you like 50 problems to do, so you just get in the habit of doing it. I prefer to make you think, and you probably prefer it too, because if you do what I'm saying, you're going to learn it much more quickly than you would by doing 50 problems and just getting in a habit that you're going to forget after. Okay? There are rules. Use the rules, know what rules you're using, and know when to use them. There are only 4 of them for this kind of an equation. Really only 2. Add the same thing to both sides, multiply both sides by the same thing. You know, here I multiply both sides by 1/3, which is the same as dividing by 3, but it could still be a multiplication. Okay? Then you have the distributive law, which you have to use here. But most people are doing fine with the distributive law, as long as it's forwards. It's got to go backwards. A little confusion on that, but we'll be talking about that shortly. Okay. Now, the next problem was A multiplied by, yeah, this chalk is just not much good. Keep having to turn it. No matter how I turn it, it doesn't write well. A times quantity, whoops, it isn't B plus C, it's X plus B. See if I can get the hang on a minute. This chalk is impossible. There's a good chalk manufacturer out there and anybody knows who they are. Don't keep the secret to yourself. Let me know. I don't know if it's going to be any better. A times the quantity B plus C equals X plus B equals C times the quantity X minus D. So far, it's a little better, but I'm not holding my breath. Okay, what do you do here? Well, you use a distributive law. Distributive law, AX plus AB equals CX minus CD. Okay. Then you probably want to get this X over here, keep this X on this side. So you're probably going to subtract AB. And it's going to leave you with AX equals CX minus CD. Now the problem is we've got an X here and we've got an X here. The X's are not all on the same side. But if you've been doing these with numbers, you know that, well, you can just subtract this from both sides and it'll be over here. Now that leads to a little bit of a complication. On this side, you end up with AX minus CX. On this side, you end up with minus CD. What do you do about that? Well, if it was 5X minus 3X, you just end up with 2X, right? If it's 4X minus 7x, you'd end up with a negative 3x. Okay, if you had numbers for A and C, you'd add those numbers together. Well, there's an operation, it's just called factoring. You could write this as x times a quantity, A minus C. Now, we went over this last time. I believe it appears in the open math videos and in some of the problems. But maybe not. And even if it doesn't, I want you to be able to do it because it's very important. You can verify by the distributive law that if I multiply x by A, I get A times x. And if I multiply x by negative C, I get negative CX. So if I use the distributive law here, I get this. So this has to be totally equivalent to this. I'm just using this distributive law backwards. I see that I've got x's here and here, so I can put the x out in front and then whatever I need in order to make divide both sides by A minus C, because whatever A minus C is, it's going to be the same as A minus C up here. So you're just dividing something by itself, leaving you x equals negative CD over the quantity A minus C. Problem comes back again to the principle that I've emphasized probably about 58 times so far in my courses, and probably about a third of that in this course. If you've got denominators, you find a common denominator and multiply both sides by that, common denominator. So we have AY plus B over C equals Y over D plus E. I'd be gratified if I saw in your work where you write denominators with 4 exclamation points, at least 4. Okay? And you could even put aha with a couple of exclamation points. Multiply both sides by CD. You get CD multiplied by AY plus B. It's not coming out right. Plus V over C, multiplying the CD by the whole thing. And when you multiply both sides by something, you simply write down what you're multiplying and you put some parentheses and you copy down the whole side. You don't shortcut anything. Okay? If you've done 100 of these, maybe you can see where the shortcut leads. If you've only done 50 of them and you're pretty quick, maybe you'll see where the saying that people are writing down enough to reinforce for themselves what is going on. You need to write out all that detail. Either that or ask me for 100 problems. I can easily give you 100 problems, okay? Or 50 or 30, whatever. But you have an assignment with about 15 problems. Do every problem as thoroughly as you can so that you learn what the problem is teaching you. And if you miss it, we'll go back and look at the notes I put in your, because I pretty consistently put notes in your work. Now, if you have a new problem penalty or another second try penalty, and you got it, then I'm probably not going to put a note in it, okay? But I look at what you did, and sometimes I will put a note if it's appropriate, okay? Sometimes I'll just miss it. So if there's a problem you missed and you still don't know how to do it, say, hey, could you look at this problem and give me a little intelligence? Provided I have a little intelligence at the time, I'll share it with you, okay? Okay, so anyhow, we have this. We write out this step. And then we'd use the distributive law. Okay, CD multiplied by the AY in the first set of parentheses gives us ACD times Y. Multiplied by the second term, B over C, we get CD times B over C. And then on the right-hand side, multiplying CD by the quantity Y over D plus E, we have CD times Y over D, and we have CD times E. We write all that out. And then hopefully we understand that the CD here is in the numerator and the C here is in the denominator. But it doesn't hurt to put the CD over 1, where we have CD multiplied by B over C, write CD over 1 times B over C. So we can see that everything here is multiplied, everything here is multiplied, and C is the same in the denominator as it is in the numerator. In other words, C is a factor of the numerator, and C is a factor of the denominator that we get if we multiply these two things out. So that C divides C, leaving us dB. And over here, the D divides the D, leaving us CY plus CDE. Now, there are a lot of letters on the page, but let's focus on what we need to do. You notice that by multiplying by the common denominator, we don't have any fractions anymore. So we don't have to worry about common denominators and putting everything over common denominator and all that stuff, which gets to be a pain. It's much easier to multiply both sides by the common denominator. And while you're at it, make a note that that common denominator cannot be 0. Because you multiply both sides by 0, you wipe out all your information. You just get 0 equals 0 no matter what the value of X is or Y. Okay, now we're trying to solve for Y, so why don't we just kind of focus on Y? We got a Y here, we've got a Y here. What are we going to do about that? Well, we want to get the Y's on both sides, and we want to get the numbers or the symbolic expressions that don't have Y on the other side. Well, first thing we're going to do then is we'll subtract dB from both sides. Now, at this point, I'm going to say, you really need then to take what I did here, write it out. A So I'm just going to put a little ellipsis here, 3 dots, and say that, okay, we've got ACDY equals CY plus CDE minus DB. Our Y's are on both sides. Now, if you had 12Y over here and 5Y over here, you'd notice subtract the 5Y from both sides, so you get a 7Y on the left. Okay? In other words, if you had a number here and a number here, I think you'd know what to do. Well, you've got symbols here, you do exactly the same thing. The operation is simply add negative CY to both sides. Okay. Now I didn't leave myself enough board room. I'm gonna have to infringe on this board just a little bit. But we get ACDY minus CY equals CDE minus, just a little more room, DB. Now what do we do? Well, same thing we did over here. We've got Y in this term and we've got Y in this term. So we can write this as Y multiplied by ACD minus C equals CDE minus DB. Now notice, incidentally, I started with a script E here, which was probably a bad idea. I wasn't thinking when I did it. You know, it's better if I write E like this because you can see it better. Okay, so I've gradually made my E a little more like printed E. Okay, so you can kind of trace the evolution of my E's from there to there. But by the time I get down here, I'm writing it in a more readable fashion. I'll try not to use the script E anymore. Okay. Well, here we have it. What do? We multiply, we divide both sides. So that this divides this, leaving us Y. The denominator divides this factor of the numerator. And there we have our solution. Okay. Now it looks a little involved because we got a lot of letters, but all we've done is we've found the common denominator, which is really easy. Your denominators are C and D, so your common denominator is going to be CD. Multiply both sides by CD, being careful, do every step, and then multiply every quantity in parentheses by the CD. So we do that and simplify it, and the denominators go away. Then we just take everything that doesn't have a Y over here and get it over here by adding the negative of that quantity to both sides using the equation negative dB equals negative dB, leaving us this equation where we still have Y on both sides, but now we know that we can just take the term having Y on one side and subtract it from both sides. And then all of our Y's will be on the left side. Then we do this kind of tricky reverse derivative law. And the rest is straightforward. It's not that complicated if you don't go blind looking at all the letters, and it's really easy to go blind looking at all the letters. Okay, look at the process. All right. As I said, you really need to get this down, and most of you need a lot more practice with formulas. So we're going to talk about linear inequalities, which are just as simple as linear equations. There's just one rule that you got to be careful of that I'll talk about in a minute, but let's just do one where you don't have that one rule. Okay, you got 5x plus 3 equals 9x minus 5. Well, you know how to solve that. You're going to subtract 3 from both sides, and then you're going to subtract 9x from both sides. You end up with negative 4x equals negative 8, and x equals negative 2. 2, not negative 2. Okay, but I'm going to change this to an inequality. Make this a greater than sign. And actually, that one rule is going to come in on this inequality. Okay, we'll see how that works. Okay, 5x plus 3 greater than 9x minus 5. Now, I can add an equality to any inequality. In other words, if this is bigger than this, then if I add the same thing to both sides, this side is still going to be bigger than this side, isn't it? So I end up with 5x plus 3 minus 3 greater than 9x minus 5 minus 3, which is the same as 5x is greater than 9x minus 8. Now my x, and I end up with negative 4x equals negative 8. And I keep writing equals. This is greater than. I have, this is greater than this. I subtract the same thing from this that I subtract from this. So this is still greater than this. Okay. Then I divide both sides by negative 4. Except that's not right. But there's a rule. It switches the inequality. So that's one thing you have to remember. when we multiply or divide by a negative number. Okay, we have to reverse the inequality. That's it. That's the only thing that's added to what you have to do with linear equations. And we get x less than 2. Now let's check this. First of all, if x equals 2, are the two sides equal? Yeah, plug in 2 to both sides here and simplify what you get. So we'll go ahead and plug in x equals 2 and write it out. What I ask you to do is plug in x equals 2. And it should be obvious when we talk about plug in x equals 2 into the original equation. So seems that I didn't stop the recording there, so there's probably some dead space in the video, but so be it. Okay, we plug in x equals 2. We have, let's write it out, we have 5x plus 3 greater than 9x minus 5. 5 times 2 plus 3 is greater than 9 times 2 minus 5. Now, many of you wanted to then subtract 3 from both sides or something like that. Well, I'm glad you're in the habit of thinking about that, and you've done it correctly, but it's much simpler than that. 5 times 2 is 10, so we have 10 plus 3. Is that greater than 9 times 2 minus 5? Well, that's 18 minus 5. Well, this side comes out 13, and this side comes out 13. Now, if this would have been a greater than or equal to sign, then we'd have had 13 greater than or equal to 13. And since 13 equals 13, it would be true. But 13 is not greater than itself. This is false. Well, we said that x has to be less than 2. X can't be 2. If x was 2, this thing is false. Now, do this and do this. Don't, unless it totally interferes with your thinking process, don't sit there and copy down everything. Get right to doing what I said. You can always go back and copy things down from the video. It's easy to find the words and so forth on the video, okay? Don't waste class time by not doing the things that I ask you to do because you want to copy everything down unless you just can't help yourself, okay? I'm just giving you advice. I'm not going to downgrade you for doing it, but you know, I just had a conversation at the gym with my ear, nose, and throat doctor. Okay, he's a generation younger than I am, but you know, we often run into each other, have a conversation, and I mentioned that you know my students don't seem to know what it takes to prepare for an exam. That's a big change over the last 2 years. And he talked about what he used to do to prepare for an exam. He said, well, first place, he'd write down every word his instructor said. His instructor must either talk slowly or he wrote really fast. But I believe him. I mean, he's not going to say something that isn't true. So, you know, that's his style. That's okay because obviously he was processing as he did that. Okay. If you're copying but not processing, sometimes you need a copy so you can go back and look at your notes. If you've got the video to look at, you don't have to copy everything I put on the board. Okay? But if it helps you learn and helps you process, I'm not going to make that judgment. It depends on your learning style. But my point is, if possible, if it doesn't interfere with your learning, if I ask you to do something, jump right into it. Don't do a bunch of other stuff. So when I come around, I can't tell if you got it. Okay? Still, do what's best for yourself. It'll be a different answer for different people. Okay, I think everybody that's completed this has come up with a false statement. A smaller number bigger than a greater one, right? Which means that your number doesn't satisfy the inequality, the solution. It's not part of the solution, and you check it in the inequality and it doesn't work. So let's say 5 is the biggest number I saw. Let's let x equal 5. Okay. We get 5 times 5 plus 3 greater than 9 times 5 minus 5. Well, that's 25, that's 28. And this is 45 minus 5, that's 40. Again, I wrote an equal sign. I think I'd be the one to get in the right habit. That's false. It had better be false because it's not part of your solution. If you find that it's true, it means you messed up something in your solution. Okay? Now, if you plug any number less than 2, it's going to be true. I'm not going to do that for you. Okay? But I'll just say, it's part of your homework. You ought to have it in your notebook. You should get a true statement. Okay, anyhow, that's all I'm going to tell you about linear inequalities. Open math might tell you a few more things, but it's just like solving equations, except you got either a greater than or less than, or a greater than or equal or less than or equal sign here. Okay? And if you multiply or divide by a negative, this is the big deal. It's the one thing you got to remember. Everything else is just like what you already know how to do. If you get a solution, check it. First check if x is equal to this number, you get a true or false statement. And you should get the same number on both sides. So if it's a greater than or less than, it's going to be false. But if it's greater than or equal or less than or equal, that would have been a true statement. Then plug in some number to one side of this number, plug in a number on the other side. Last thing I'll mention, you could then graph this and it tells you how to do that. Okay. Here's x equals 2. And here's your solution set, all numbers to the left of 2, not including 2. So all the numbers over here are going to make this thing false. All the numbers over here are going to make it true. And you could also write this as negative infinity to with an open parenthesis. That's also, I think, been part of your homework. Okay. Solution set. If not, you'll see it in this assignment. Okay. Now, I remember talking about this, but I think it was in the pre-calculus support class. I think it would have been in here. And if I did talk about it in here, forgive me, but we're saying twice. Okay, so let's say, first of all, what's the absolute value of 8? And what's the absolute value of negative 17? Let's quickly write this down and tell me what you think the absolute values are. There's no reason necessarily that you should know. I just want to see how much I need to say. Let's say the absolute value of 8 is 8. And the absolute value of negative 17 is 17. Okay. If the number is negative, then the absolute value is the negative of that number. The negative of negative 17 is plus 17. Number line, here's x equals 8. That was a bad choice of where to put it, but just extend my line a little bit more. And let's say x equals 0 is here. X equals negative 17 is here. You can think of the absolute value as how far the number is from x equals 0. If you go from here to here, how far did you go? 17 units, right? 17 units in the negative direction, but it's just how far was 17 units. If you had to walk from here to here, you'd have to go 17 units to get there. Okay. So that the absolute value of negative 17 is how far, and that's like you take the negative 17 and flip it over to the other side of the axis. Okay. That's the first thing you've got to understand about absolute value. One more thing. Say absolute value of x equals 17, then what is x? Well, x equals 17 is a solution because the absolute value of 17 is 17, right? But x equals negative 17 is also a solution. Now, just quickly to close, if you have absolute value of 2x plus 6 equals 17, that means that 2x plus 6 could equal 17, or six could equal negative 17. You can solve this equation and get x equals 23 over 2, or you get, x equals 11 over 2, x equals negative 23 over 2. If I solve those correctly, you get two solutions. The absolute value equation breaks into two equations. Now, there's a good bit more to absolute value that we'll talk about next time, but make sure you understand this much when you come in, so you can understand everything else. Okay, thank you.